Hello students. Today we'll be discussing about energy and power signals for continuous time signals to estimate whether the given signal is an energy signal or a power signal. So the given expression is to find out whether the given signal is energy or power is energy of a signal is given by E equal to integration minus infinity to infinity modulus of x of t the whole squared dt, right? So energy contained in the signal, you can just compare it to what is meant by an energy, right? Energy is nothing but the amount of work done for a specific period of time. That is called as an energy, right? Just like moving a chair and then walking for a specific distance, that is called as actually energy, right? So the mathematical representation of that energy is it is uh, the signal x of t square it and integrate it with respect to minus infinity to plus infinity, right? And what is called as power? So power is nothing but this energy averaged over an infinite amount of time period is called as power. So here you can see that the expression for average power is you first find out the power of the signal for a specific time period. So that you are finding it as square integrate of x of t the whole square dt from minus t to t and average it for that specified time period, which is nothing but 2t, since you have taken it as minus t to 2t. However, this power averaged over an infinite amount of time period is nothing but the average power present in your signal. If you want to try to just take a physical representation for this, you can compare energy of a signal to that of a battery, right? You consider a battery which is chargeable or not chargeable, right? The amount of energy stored in that particular battery is said to be finite, right? But whereas when you try to relate that energy to a person's lifetime, which we consider to be an infinite amount of time, right? So when we calculate the average power, that is the energy distributed over an infinite amount of time, the power will become equal to zero. So the energy divided by infinite amount of time will be equal to zero. So that extends into the first point. If the signal is an energy signal, right? The energy of the signal is finite, right? That means you have this energy which lies which is lesser than infinity. It is not going to be infinite. It's going to be a finite. So if the signal is an energy signal and if it is finite and if you try to average that power for an infinite amount of time period, automatically the power will be equal to zero, right? Next, when can a signal be called as a power signal? So a signal is said to be a power signal if the power of the signal is finite, whereas here the power of the signal is finite. That it is lesser than infinity, it's not equal to infinity, it is lesser than infinity, it is some finite value. Whereas the energy of that signal becomes equal to infinite, right? A simple analogy of this power signal, you can compare it to a sun's radiation, right? A sun, why it is said to have infinite energy? Because it never stops giving us radiation, right? There is continuous radiation which is provided for a person's entire time period. So, obviously, the energy contained in that particular sun is said to be what? Infinite. Whereas, that amount of energy pertained in a particular person's lifetime will definitely be finite since the energy is said to be continuous. So, if a signal is a power signal, the power of the signal is finite and the energy is infinite. In certain cases, if the signal does not satisfy any of the conditions, that is, it does not satisfy either one and as well as two, then the signal can be classified as neither an energy signal nor a power signal. So it is important for you to keep into mind these two formulas and then the condition to check whether the given signal is an energy signal or power signal. In general, in short, you can remember that any signal which exists for a finite time period can be called as an energy signal, whereas a signal which extends for an infinite amount of time. For example, a sinusoidal signal which can execute or which exists for an infinite amount of time can be called as a power signal. Whereas a signal which exists for a short time, for example, just a square pulse for a specific duration, will be considered as an energy signal. All these you will infer when you solve the problems with the different type of these signals. So let us determine whether the signal x of t equal to e power minus 2t u of t is an energy or power signal. So based on the discussion that I told you earlier, you just try to analyze just to have an understanding of the signal, you just try to understand what the signal is. E power minus 2t. It is a real time decaying exponential signal, right? And it is multiplied with u of t. U of t is nothing but a signal which exists from 0 to infinity, whereas e power minus 2t is nothing but a decaying exponential signal. So let us analyze whether it's an energy or power signal. So you take the signal, the formula is energy equal to minus infinity to infinity, e modulus of e power minus 2t u of t the whole square dt. The next step will be you have to integrate this. So before integrating, you can remove this u of t, right? How do you remove this u of t? U of t is nothing but your unit step signal, which is equal to 1 for t greater than or equal to 0. So obviously, this integration can be replaced by 0 to infinity and u of t can be made as 1. So that is what has been done here. So here it should be actually here 0 to infinity. So this should actually be 0 to infinity. So from 0 to infinity, u of t will be replaced as 1 and modulus of e power minus 2t the whole squared can be written as e power minus 4t dt. A very simple modulus of e power minus 4t. It's just a real, it does not involve any complex. So automatically e power minus 4t dt. Integrate e power minus 4t by minus 4. Integration from 0 to infinity e power minus infinity is nothing but 0 minus e power 0 is 1. So you will be getting the resultant as 1 by 4. So energy is equal to 1 by 4. So you can also try to understand here the energy is finite. Why the energy is finite? Because e power minus 2t is a decaying signal. So even when it is multiplied by u of t which extends to infinity, the resultant signal will be a finite signal. So since it is a finite signal, you are getting energy also as finite, right? Next, we need to find out what is a power, right? To be as an energy signal, you should not only find energy, but you should also find the average power, right? So going on to find the average power. So power is given as limit t tends to infinity. See, it's very important. First, you need to find this factor. That is integration minus t to t e power minus 2t u of t the whole square dt. And then you have to divide it by 2t, right? So it is not 2 pi, it is 2t, right? You average it for this time period 2t, and after finding this integration, then you have to finally substitute limit t tends to infinity, right? Please do not do the mistake of substituting t tends to infinity in the beginning itself. You should evaluate this integral and after that only you should substitute t tends to infinity. So proceeding here, everywhere it is t to infinity, it should be t. So instead of pi, it should be t. So t tends to infinity. So e power minus 2t the whole squared. And then here it is in removed u of t. So obviously it should be 0 to t u of t. So you can see that here it is t tends to infinity 1 by 2t integral 0 to t e power minus 4t dt. Integrate this. So when you integrate, you will be getting 2t integral 0 to t e power minus 4t dt. So limit t tends to infinity, 1 by 2t e power minus 4t divided by minus 4, integration limit 0 to t. So 1, 2t into minus 4. See, you can see that I am not substituting t to infinity till now. I have to complete fully all this integral. So 1 by 80 e power minus 4t 0 to t. Substitute the limits. E power minus 4t minus e power 0 minus 1 by 80 e power minus 4t minus 1. Limit t tends to infinity 1 by 80. Right? So this minus. So 1 minus e power minus 4t. After this, is there any possibility of simplification here? Right? So I am concluding that after this, there is no possibility of simplification. Once I reach that point, then you substitute t tends to infinity. So when you substitute, what you get? 1 minus e power minus infinity divided by infinity. You know very well that e power minus infinity value will be 0. So 1 minus 0 will be 1. 1 divided by infinity. What is 1 divided by infinity? It will be 0. So you can see that for this signal, energy is finite whereas the power is equal to 0. Hence, the given signal is an energy signal. So we are again asserting the fact that if the signal is going to be contained for a finite amount of time period, then the signal will obviously be an energy signal. Moving on to the next example. So determine whether the signal x of t is equal to cos t is an energy or power signal. Just take a pause and just think about the signal and what we told earlier related to a power signal. Yes, I have told you earlier that this is just a intuition for you to get an idea of the problem. However, you have to prove everything analytically also. I've told you that if any signal exists for an infinite amount of time period, then that signal is said to be a power signal, right? So here you can see that x of t is equal to cos t. Here t is not defined, so it can take anywhere between minus infinity to infinity. It's a cosine signal when you that extends from minus infinity to plus infinity. So definitely for this you will find out that this signal will be a power signal with a finite amount of power and energy will become infinite. So I have given you the answer actually, right, before proceeding on to the problem. This is just to give you a understanding of what is a power signal, right? However, it should be proved quantitatively. So how do you prove it quantitatively? Go into the same similar formula. So energy equal to x of t the whole square, square integration, cos t the whole square dt. So integration minus infinity to infinity, cos square t dt. So how can you integrate this? Cos square theta can be written as 1 plus cos 2 theta. See, directly you cannot integrate, right? So you need to expand it into 1 plus cos 2t divided by 2 into dt. So here 1 by 2 common integration 1 dt plus minus infinity to infinity cos 2t dt. So obviously when you integrate 1, you will be getting t plus sine 2t by 2, right? So now when you substitute for here t infinity itself, the first term will become infinity. Infinity added with any signal will definitely be infinity. So you will be getting that the energy of this signal is said to be infinite, right? Then we need to find out what is the power of the signal. So moving on, apply the formula for power. So as I told you earlier, it is very important while calculating power that you should find out this entire integral and then only finally substitute limit t tends to infinity. So keeping this in mind, we are just finding 1 by 2t minus same thing cos square dt infinity 1 by 4t because 1 plus cos 2t divided by 2. So that will become 4t and then we are proceeding limit t tends to infinity 1 by 4 t, the limit is minus t to t plus sine 2t by 2. So integrate cos sine 2t by 2, the limit is from minus t to t. So here the limit, this is small, so it should be, this is not there, so the limit will be from minus t to t. So automatically limit t tends to infinity 1 by 4t 2t, right? So you substitute here t minus t, you'll be getting 2t. then sine 2t minus sine of minus 2t divided by 2, right? So here what is sine of minus theta, sine of minus theta, that is equal to minus sine theta, right? So next step will be limit t tends to infinity, 1 by 4t, 2t as it, sine 2t, sine of minus theta is minus sine theta, so it is given as plus sine 2t divided by 2. So simplifying further, you will be getting 2t plus sine 2t. Is there any other further simplification that is possible? I don't think so. You can simplify further. So now what you can do is you can substitute limit t tends to infinity, right? So when you substitute t tends to infinity, okay, still more simplification that is possible is you have a t here as well as you have a t here. So what we are doing is limit t tends to infinity, 2t divided by 4t is 1 by 2 plus sine 2t divided by 4t. It's a very important step, right? You have 2t here, you have 4t here. There is a possibility of simplification. So that we are extending by dividing, and after this, what we are doing is 1 by 2 is as such. Since further simplification is not possible, I am substituting t tends to infinity, right? So this 1 by 2 is undisturbed, whereas this second term, sine of some value divided by infinity becomes equal to 0. So you are getting the power is equal to 1 by 2. Hence, in this signal, power is equal to 1 by 2 and energy is infinite. So we are proving again a fact that this signal, cos signal, which extends for an infinite amount of time period, is said to be a power signal with finite amount of power and infinite amount of energy. Just you compare it with respect to sun, right? Cos signal and sun, cos which extends for infinite amount of time period. Sun, it extends for an infinite amount of time period. It gives us energy continuously. That is why the energy contained in the cos signal or parallelly the sun is said to be infinite, right? But whereas when you try to average this signal energy for an infinite amount of time, for a person's time, we get a finite amount of power which is given by 1 by 2, right? A very important takeaway from this particular thing is you can look here, if the given signal is of cos form or it is in the given in the form of sine form, in 2 mark questions if you are asked to find the power, this power is nothing but the amplitude square divided by 2, right? You take the same problem. So in our problem, what was a given signal? The given signal is x of t equal to a cos t, where the amplitude a equal to 1. So in 2 marks, if you are given this problem, to find out power, you can simply take power is nothing but a square divided by 2. So what is a here? 1. So 1 square divided by 2, which is nothing but 1. So that is a very important takeaway from this particular thing. So if the given signal is a cos or sine signal, then the power is given as a square divided by 2. What do you need to note? All periodic signals. So when you do a lot amount of problems and explore more, you will come into this conclusion. All periodic signals are called as power signals because they supply us with infinite amount of energy, and that energy averaged over a specific interval, infinite amount of time will be a finite power. So all periodic signals are power signals. All non-periodic signals are called as energy signals. That is, a signal which is aperiodic, which can exist only for a finite amount of time, are called as energy signals. To extend further, if you're asked to find the root mean square value of a signal, it is nothing but square root of the average power of the signal. So let us move on to one more example. Determine if x of t equal to a, t greater than or equal to minus t naught, lesser than or equal to t naught, 0 otherwise is an energy or power signal. Pause the video, take a minute to understand what this signal is. Without even going analytically to the procedure, try to guess whether the signal is an energy or power signal. Right? I think you would have guessed, right? This signal is said to be what? This signal is existing for a finite amount of time. See, the amplitude is A between what? Only from minus T naught to T naught, right? So this signal is a finite signal. So a finite signal will definitely be an energy signal, right? A signal which has only for a specified time period it exists, right? So that type of signal is said to be an energy signal. So let us see whether you're getting the same answer after you do a quantitative approach to this. So the same signal plotting, right? So x-axis with respect to time, amplitude A. So actually this should be the amplitude A, right? So the amplitude of this signal here is nothing but A. It exists for minus T naught to T naught, right? A can be 1 or 2 or 3 or. So remaining part and all, the signal is said to be 0, right? Let us go on to calculate energy. Energy is minus infinite to infinite modulus of x of t the whole square dt. And here automatically what will happen to the limit? From minus infinity to minus t naught, the limit, the value of the signal is 0, right? So minus t naught to t naught alone, the signal exists. T naught to infinity also, the signal is 0. So minus t naught to t naught modulus of a squared dt. So simplify it further. A squared, right, dt, a squared t, integrate, you will be getting a squared t a squared t naught plus t naught. What is it? Yeah. So you'll be getting energy is equal to 2a squared T naught. So you can find out that the energy of this signal is finite, right? Still you need to find out the power, right? So going on to find out the power, find power is equal to limit t tends to infinity 1 by 2t integration minus t naught to t naught modulus of x of t the whole square dt. So 1 by 2t minus t naught a square dt. Same thing you proceed. Uh, do not simplify, do not substitute t tends to infinity till you simplify this continuously. So a square t naught plus a square t naught. So you'll be getting a squared 2a squared. So that should be actually a squared here. Okay, so actually you'll be getting 2a squared T naught divided by T, right? After the simplification, see T naught and T are different. T naught is some variable which can be, a T naught can be 1, T naught can be 2, T naught can be 3, it depends upon the signal, right? So don't cancel out T naught and T naught. So it is equal to 2 a squared T naught, right? Divided by, substitute for T equal to infinity. So when you substitute for T equal to infinity, here obviously, a finite value divided by infinity will be equal to 0. So you're getting power as 0. The energy is finite and power is 0. Hence, a given signal is an energy signal. So based on what inputs you have taken on, just to do this practice problem, determine is x of t equal to e power j 2t plus pi by 4. Determine whether it's an energy or power signal. The hint is you need to apply Euler's formula during simplification. Thank you.